Okay, we're going to look at Calculus Part 7, functions and their first and second derivatives. If they sometimes give you these graphs or these situations where we really have to understand the first and second derivative, and they're a bit more challenging, exactly what's going on. And we have some notes and some graphs that are going to help us understand the relationship between these things, between the first derivative and the second derivative, and how they relate to each other on a graph. Well, the first thing you have to know is that if f of x is increasing, that means that the gradient f prime of x is greater than 0. It means it's positive. It also means as you move from left to right, it's going up. When the graph is decreasing, it means that the derivative is less than 0. It means the gradients are all less than 0. And it means it's going downhill as you move from left to right. It's decreasing, just what it says. But when it hits a local maximum or minimum or turning point there, it's stationary. The derivative is equal to 0. Well, let's see what this looks like on a graph. And we have this very nice graph right here. Well, there's the blue cubic function. There's a blue cubic function. And a is a local maximum, b is a local minimum. We can see x-intercepts and y-intercepts. But this red graph is the graph right on the very same graph of the gradient, f prime of x. Well, that's pretty weird. Let's try and figure out what's going on. What is happening here? Well, the first thing, look to the left of the dotted line. These, on the blue thing, we can see that the gradients are positive all the way here, that it's increasing. And that's why f prime of x is greater than 0. It's because these gradients are greater than 0. What about in between the two dotted lines? Well, between the two dotted lines, it's going downhill, and it's decreasing. Well, that's why the derivative, the graph of the derivative, that's what we're graphing the derivative, it dips below the line. Below, there's 0. Look, it's gone down. It's all negative down here. And then we asked the question in the notes, what do you think's happening to the right? Well, these gradients are all positive. It kind of makes sense that the graph of the gradient of the derivative, which is really the gradients at any value of x, it makes sense that they're above 0. Look, it's greater than 0. So every part makes sense. Negative gradients below 0 here. Positive gradients, the derivative is above 0. Positive gradients here, the derivative is above. So if all that makes sense to you, you're going to find these questions easier.